Dear faculty members and my dear students, I welcome you all once again to join with me to discuss a few things on time, distance, and speed. The problems of time and distance play an important role in aptitude tests. There are three types of problems in this case. One, problems on cycling of a man or running of a car or motorbike, etc. Two, problems on trains or crossing of trains, etc. Three, problems on boat and streams. To solve these problems, we use the most fundamental formula speed equal to distance by time or time equal to distance by speed. Average speed. If a certain distance is covered with x kilometers per hour and another equal distance with y kilometers per hour, then the average speed will be 2xy divided by x plus y kilometers per hour. This formula is obtained by calculating the harmonic mean between x and y. We note that this formula is used when the distance traveled is the same for x and y. Now, if a distance is covered with a speed of x kilometers per hour and another distance with y kilometers per hour, the time interval being the same, then the average speed will be x plus y by 2 kilometers per hour. We note that this formula is used when the time interval is the same for both the speeds. If the ratio of the speeds is x is to y, then the ratio of times taken will be 1 by x is to 1 by y. The time taken by a train of length L meters to pass a stationary object, maybe a pole, is the time taken by the train to pass length L. Boating problems. Speed of the boat in upstream will be equal to speed of the boat in still water minus speed of the current. Speed of the boat in downstream will be equal to speed of the boat in still water plus speed of the current. Using these two relations, we get the formula speed of the current equal to 1 by 2 into speed of the downstream minus speed of the upstream. Relative speed. If two objects move towards each other with the speeds a and b respectively, then the relative speed will be a plus b. And if the two objects move in the same direction with the same speeds a and b respectively, then the relative speed will be a minus b. Now we'll discuss some problems. One, a bike covers certain distance at a speed of 64 kilometers per hour in 8 hours. If the bike was to cover the same distance in approximately 6 hours, at what approximate speed should the bike travel? From the given data, when the time taken is 8 hours, the speed is 64 kilometers per hour. We have to find out the speed when the time taken is 6 hours. We know when the time is decreased because it is from 8 to 6 decreased. When the time is decreased, the speed will be higher so that the equal distance can be covered. Therefore, the required speed must be equal to 64 into 8 by 6 kilometers per hour. Problem number 2. A car covers a distance of 300 kilometers at a constant speed. If the speed of the car is increased by 5 kilometers per hour, it takes 2 hours less to cover the same distance. Find the original speed of the car. Solution. We assume that the original speed of the car is x kilometers per hour. Then x equal to 300 by t, where t is the time taken. When the speed is increased by 5, then x becomes x plus 5 and the time is decreased by 2 hours. Therefore, instead of t we are having t minus 2. Therefore, x plus 5 will be equal to 300 by t minus 2. By eliminating t between these two relations, we get an equation, quadratic equation, x squared plus 5x minus 750 equal to 0. Solving this equation, we get a positive value of x as 25 kilometers per hour. Problem number 3. The speeds of 3 cars are in the ratio 1:2:5. Find the ratio of times taken by the 3 cars to travel the same distance. We know the relation when the distance is the same and the ratio of the speeds is x is to y. The ratio of the times will be 1 by x is to 1 by y. Here, the required ratio will be 1 by x is to 1 by y is to 1 by z, where x equal to 1, y equal to 2, and z equal to 5. Therefore, the required ratio is 1 by 1 is to 1 by 2 is to 1 by 5. Multiplying by throughout 10, the required ratio is 10 is to 5 is to 2. Next one. A train 130 meters long passes a bridge in 20 seconds, moving with the speed of 90 kilometers per hour. Find the length of the bridge. Let the length of the bridge be x meters. Then the total distance the train covers will be 130 plus the length of the bridge, that is 130 plus x. Therefore, the speed of the train will be equal to, actually it is given that 90 kilometers per hour. We convert the unit. So we are multiplying by 5 by 18. So the speed of the train will be 90 into 5 by 18 meters per second. Also, the speed of the train will be distance by time, that is 130 plus x divided by 20 meters per second. Both these speeds will be equal. Therefore, 90 into 5 by 18 will be equal to 130 plus x divided by 20. Solving this relation, we get x equal to 370 meters. That's the solution. Next problem. Two trains start from A and B respectively and travels towards each other at a speed of 50 kilometers per hour and 75 kilometers per hour respectively. By the time they meet, the second train traveled 40 kilometers more than the first. Find the distance between A and B. The starting point of the two trains are A and B. Actually, it is given that they move each other, that is, they move in the opposite directions and meet at the point M. We shall assume that the distance between the points A and B, that is x equal to small x equal to AB. Therefore, since M is the meeting point, since it is given that the second train traveled 40 kilometers more than the first at the meeting point, we know that, or we conclude that MB equal to x plus 40 divided by 2, where x is equal to AB. Using this relation, we can get AM equal to x minus 40 divided by 2. If you add these two things, x plus 40 by 2 and x minus 40 by 2, we will get x. We know that time equal to distance by speed. Therefore, we can get time in two different ways. One is starting from A and the other is starting from the point B. Starting from A, at the meeting point, the time taken will be equal to x minus 40 divided by 2 divided by the speed. Time equal to distance by speed. So x minus 40 by 2 divided by 50. In the same way, starting from the point B, at the meeting point, the same time is attained. Therefore, the time will be equal to distance by speed. So again, it will be equal to x plus 40 divided by 2 divided by 75. These two times are equal. Therefore, we get a relation x minus 40 by 2 divided by 50 equal to x plus 40 divided by 2 by 75. Solving this equation, we can get x equal to 200 kilometers. Next problem. A boatman can row 48 kilometers downstream in 4 hours. If the speed of the current is 3 kilometers per hour, find in what time will he cover 15 kilometers upstream. We assume that the required time is t hours. The speed of the downstream will be equal to 48 by 4 kilometers per hour from the given data, because the distance is 48 downstream, it is given, and the time is 4 hours. Therefore, the speed of the downstream will be equal to 48 by 4 kilometers per hour. In the same way, the speed of the upstream will be equal to distance by time. That is, for the upstream, the distance is 15 kilometers per hour. Therefore, the speed of the upstream will be equal to 15 by t kilometers per hour. We know the relation speed of the current equal to speed of the downstream minus speed of the upstream divided by 2. But it is given that the speed of the current is 3 kilometers per hour. Therefore, 3 equal to 12 minus 15 by t divided by 2. Solving this simple relation, we get t is equal to 2.5 hours. That is 2 hours 30 minutes. Thank you.